Students, now we are going to understand some of the terminologies which will be very useful in understanding some applied concepts. For example, what is analytic function and what is harmonic function and so on. Okay, so let's just begin with some of the concepts. For example, set of points in the complex plane. Okay, these understanding will help you in finding limit, continuity and differentiability of a complex function. Okay, alright, let me just begin. So if you will assume, what is this? By the way, you must understand this is a circle whose center is at z0. Alright, now you understand that you can write it like x minus x0 whole square plus y minus y0 whole square is equal to del square, right? So circle's center is x0 y0 and its radius is del, and you can assume that del to be small. Del is small. Okay, now if I say, so this is a circle, right? So if I ask you to draw a circle z minus z0 is equal to r, right? So this is a circle, right? If I say give me a point on this circle, let me not consider it r. Alright, so if I say give me a point on the circle, okay, so what would that be? Z0 plus del into e to the power I theta. Alright, so theta will go one round in the counterclockwise direction. Okay, alright, now if I say plot a geometry for this mod of z minus z0 less than r, so this is dotted by the way. So all this region, every point within this except on the circle, it is called open disk. Okay, now what would be closed disk? Of course you understand, if you will include points on the circle, then that would be open disk. Alright, now why are we doing this? You will see in a while. Okay, so I have list of points that you need to understand. I will just mention one by one. Alright, now just two more things, open annulus and closed annulus. So if I say this, what would it be? If this inner radius is r1 and outer is r2, then this is closed annulus. So closed annulus would be z minus, of course, at z0, and this would be between r1 to r2. And what would be open annulus? This has to be dotted. Okay, mod of z minus z0, this equality sign will be removed. Okay, now see, I explained these things. Based on these geometries we will understand. For example, neighborhood of a point you will understand. You will understand what is interior point, exterior point and boundary point, and then open set. So you will understand open set, then closed set, bounded set. Based on that you will understand connected set and domain and region. So basically I am leading you towards the domain and region. Okay, let me just see one by one. So have patience, these things will be used and they will help you in understanding applied concepts further. Okay, you will solve those questions as well. Okay, so let me just start with neighborhood of a point. Neighborhood of a point. What is neighborhood of a point? It's nothing but an open disk centered at z0. Okay, where delta is, this del is very small, or delta. Now if I say remove z0 itself, okay, if you have to draw geometrically you can do that, right? So if z minus z0, this is less than r, so this is r. If you choose a point here, point P, okay, so this is going to be, whose radius is what? Del. Then that point P would be mod z minus z naught less than del, or instead of this r you can consider directly del. So this open disk of radius what? Del, centered at z naught would be neighborhood of a point. Okay. Now if I say remove z naught from this neighborhood of a point, then what would it be? Del. Okay. So this is called deleted. Okay. So this is what? Deleted neighborhood. Deleted neighborhood of a point. Okay. Now next is interior point. Of course, if you consider, by the way, this open disk, this is open disk. So if you consider this open disk, then interior point would be any point P. So like I had put point P here. Okay. Interior of that disk. What will be exterior point? Of course, any point here. Okay. So boundary point, of course, if you draw closed disk, right, then this would be boundary point. Let's say Q. What else? Open set. All set S is open if every point of S is an interior point. Okay. How will you write it? So this is open set. Open set is important. It is linked to many further understanding, further concepts. For example, S is open set if every point of S is an interior point. Okay. So S is what? Z, and interior point would be this. Okay. This is a disk of radius r in the neighborhood of z naught. Okay. So this is an open set. So all the points, I'll read it again. A set S is open if every point of S is an interior point. Alright. Now what is closed set? Okay. So what is closed set? Closed set is if every boundary point of S belongs to S also. That means right now all the points are interior point, then open set. For example, closed set, then it would be Z, and where Z minus Z naught is less than or equal to R. So this is basically closed disk, right? Now what is bounded set and unbounded set? It is similarly related to this closed and open set and bounded set, right? So I'll read it in sync with the whole statement so that you would understand. So bounded set is an open set where magnitude of this, there exists a Z where this Z minus Z naught is less than some value, right? I'm going to call it R. Okay. So S is bounded set. Bounded set is an open set where this Z minus Z naught, this magnitude is less than some value, that is here in this case R. What is unbounded set? Unbounded set is also an open set where this is always greater than some value. Okay. I will explain, you'll understand with the diagram better. Okay. So you understood bounded set. Couple of more terminologies that will help to understand other things. So I have been keep telling you. Now let's talk about connected sets. What is connected set? So connected set is important to understand domain and region. Okay. So what is connected set? Connected set, an open set S is connected if any 2 points Z1 and Z2 belonging to that open set S can be joined by a polygonal line. What is polygonal line? That means you draw a line in a multiple segment. Okay, I'll show you by drawing it. So what is connected set? If I say this, let's take an open disk, right? If you take an open disk, this is Z0 of course, and there is point Z1, Z2. So if I take open disk, then that is an open set, right? So connected set is an open set where if you choose 2 points, you can join them by a polygonal line or line segments. Okay. So if I'll take this region, and here it is a cavity, you can say, then 1 point here, Z2. Join it. How will you join it? Can you join them directly? No. So you can join them through a line segment. Okay, polygonal line segment. Okay, so then this is a connected set. Now understand domain. What is domain? So for real valued function, you understand what is domain, right? So domain and region we will do. Domain. So domain is where function is defined. All those values of x where function is defined. This is what we studied. So what is domain? Domain is all those values of x where function is defined, right? So in this case, you can say an open, I'll write it, an open and connected. This is important. An open and connected set is a domain, right? Is a domain. Of course, that is still applicable where you say that in case of fz, what is the domain of fz? So all those values of z where fz is defined. Alright. Now, whether it is bounded and unbounded doesn't matter. So you have to focus on open and connected set. If a set is open and connected, then that can be called a domain of a function. Okay. What is region? So domain is denoted by D and region is denoted by R. Okay. What is R? Region is a domain together with all, some or none of its boundary points. So like as I said, open, it should be open, right? Domain should be open, but region, in case of region, so in case of domain, what was it? Boundary points, it's an open set, right? So boundary points cannot be included, okay? Only open disk. But in case of region, some of the boundary points can be included, none of the boundary points can be included, all of the boundary points can be included. Okay, so something like this, closed disk. So a domain can be a region, but a region cannot be a domain. Alright, I hope you understood. Now, extended complex plane, this is the one of the last topic that we have to cover in this. Extended complex plane. What is extended complex plane? Extended complex plane, what is that? A complex plane to which the point at z is equal to infinite has been added. Okay, so at z is equal to point at z is equal to infinity, point at z is equal to infinity has been added, then what will you say? Extended complex point, right? And if this complex plane without point at z is equal to infinite, then what will you say? Finite complex plane. So finite complex plane. So what is finite complex plane? Where point at z is equal to infinite is not added to your domain, right? So let me just take example. You have to plot z. So basically I am going to take example. So you have to tell whether they are domain or not. Real part of z not equal to 0. Tell me whether it is domain or not. Okay. So let me just talk. What is real part of z? X. So basically x. Alright. So real part of z not equal to 0. Right. That means x not equal to 0. What is x? Okay. So what is x equal to 0? This y-axis, imaginary axis. So you will exclude this. Okay. So this one, but excluding y-axis. This is what? By the way, this is open. This is not connected. This is not connected. Why? Take one point here, take one point here. Will you be able to add them? No. You'll have, let's say you want to, so directly you cannot add because y-axis is not included. So you might think, okay, let's go there. Where will you go? Till infinite. So you cannot connect them. Not connected and unbounded. So for domain, you have to basically classify them either as domain or region. So this is not a domain. So if not a domain, but it can be region. So not connected, unbounded. Whether it is bounded, unbounded, doesn't matter. It has to be open and it has to be connected for it to be classified as domain. Okay. So this is not a domain. Let's take another example. I'll take just couple of them, not a lot. So second, z where imaginary part of z is greater than 1. Okay, tell me whether it is domain or region. So what is imaginary part of z? Y is greater than 1. So plot it. This is x or real part, this is imaginary part. What is y equal to 1? This. So y greater than 1 would be all this. It is connected, it is open, and it is unbounded. So it is a domain. Okay. So another is, can you classify z where imaginary part of z is less than mod of z minus 1 whole square. Put z is equal to x plus iy, both sides, solve it, again convert it into this form, z minus 1 plus I by 2 mod is less than 1 by 2. Basically a circle centered at this and satisfying this inequality of radius 1 by 2. So if you plot it, this is how it is going to look. Okay, so this is 1 comma half and radius half. So what is the region? This one. Okay, so this is again open, connected and unbounded, so it is going to be domain. Okay, one last. So if you plot this, what will you get? This region. So is it open? No. You are including the boundary points, right? Is it connected? Yes. Is it bounded? No. It is unbounded. You can go till whatever extent you want. So it is unbounded, it is connected, but it is not open. So it cannot be domain. Okay, so this is not a domain. Okay, so thank you so much for watching the video. Do subscribe to the channel, and I will in the next video I will continue from limit, continuity, differentiability, analytical function and harmonic function and holomorphic function. Thank you.